Very good afternoon to one and all.
Today I feel very proud and equally excited to present you a very awesome and informative topic named History of Mathematics. We see here how mathematics came into being and what was the necessity to develop mathematics in our life. Basically, we need food and shelter for our lives to sustain it. For the food, we need crops of different varieties, we need different seasons. But in early ages, there was no calendar, no things to calculate the time or weather. Early Paleolithic people tried to evolve a new pattern to develop their calendar by using mathematics. At the time of winter, they carved tally marks on carved stones. For example, they put one and called it winter, another one and they called it summer season, another one and they called it autumn, and so on. But after counting too many ones, they forgot where from they started. Now, how will they do their plantation, which required different seasons and weathers? To begin with, around 3,000 years ago, early human beings searched these techniques for their planting and for their breeding purposes. Especially Paleolithic people, they were very smart and outstanding people. Even though they were early humans living in caves, but anyhow maintained how to draw some patterns, to draw weathers, seasons and calendars. They counted things using their fingers, but at that time there was only 10, 5s, because we have in our hands 5 fingers and 2, it is 10 fingers, 15 and 20 and so on. But there was not an idea how to count other than these numbers. Some other cultures evolved at the time and they maintained how to measure numbers. Around 4th millennium BC, a number 1 was designed like a small cone. A number 10 was designed like a large circle. And number 60 was designed a largest cone. But they had to draw these things. They preserved these stones in their caves and certain areas. Again, after this, Babylonians, a civilization came into being. Babylonians actually belonged to Iraq, now called Iraq. They again draw some other patterns for 1, for 10 and so on. They used nils for 1. They used inverted V, laterally inverted V for tens and so on. In this way, civilization evolved and the number system started. After that, Egyptian came with a new idea to present their number systems. They show with their real life objects to present the number. For example, they called 1 a rod. A rod was actually called 1 at that time. A cattle hobble was used to show a number 10, and a coiled rope was used for 100, and a lotus flower was called 1,000 at that time. Because that time no number system was there as it is now, because we are living in modern period, after modern period. After this, the Roman came with the idea to present their numbers that we actually read now. We all are aware about Roman numbers and numerals. After that, there was a need for adding, subtraction, and multiplication. A new civilization from Nigeria, we called from Yoruba. They used cowrie shells, because cowrie shells for different patterns for addition, subtraction, and multiplication. We will use, they use these things in their addition, subtraction, multiplication. If I can write on pattern, for example, they use some six types of shells for addition, subtraction. They devise some cells. I will draw it on patterns later on. For example, they draw certain patterns. They call it entry. They draw certain pattern to draw it, add, and some ellipse-like pattern to draw minus. They use their number system to add, subtract, and multiply. Before moving onwards, I would like to give the parts of mathematics according to their history. The history is divided in ancient period, Greek period, Indo-Arabic period, period of transmission, early modern period, and modern period. Regarding ancient period, I have already told some civilization came into being and draw certain patterns to write the number system. Ancient period began around 3000 years BC, and number system and arithmetic was introduced. Development of numeration systems. They are the time when numeration system developed. Creation of arithmetic techniques, lookup tables, and the abacus and other calculation tools were designed. Now we have modern calculator and computer to solve, add anything. But at that time, they had tablets for their purposes. Abacus tablets made up of wood, the Chinese use these things, and other calculation tools. Practical measurement, geometry, and astronomy. Measurement units devised to quantify distance, area, volume, and time. It was the time when the units were devised. Geometric reasoning used to measure distances indirectly. At that time, geometric reasoning was also involved. Calendars invented to predict seasons, astronomical events. Calendar was also invented. And geometrical forms and patterns appear in art and architecture. We can see their patterns now. As I have already told that Babylonians, this was found in a slate, and some patterns were given for numbers. You can call it 1, 2, and other numbers. Practical mathematics. Actually, there was a need to develop buildings, roads, canals. They used their mathematics, and ancient civilization has developed. The need for practical mathematics increased. They required numeration systems and arithmetic techniques for trade, measurement, strategies for construction, and astronomical calculations to track the season and cosmic cycles. These are the ancient civilization which developed the calculator constructions, astronomical calculations to have a record of seasons for the planting purposes. This is Babylonian numerals. Now we use Pythagorean triplets. This was Pythagorean triplets that was designed on a piece of slate and found in architecture. These numerical system used only two symbols and a base of 60. At that time, we don't know every numbers 0, 1, 2 till 9. At that time, they used only those two symbols. One was for base 60 and other two symbols for its power. Pictures are vanished, but we know calculator, how to use calculators. These were calculators of that time. These were the calculator of that time, but very difficult to handle it. Everyone cannot use it. They have to learn how to use it. But modern calculator, everybody can use it, whether it is graduate or non-graduate or even matriculate can use it. But for using these calculators, a special techniques were developed. Now, Greek period. It started around 600 BC. Greek logic and philosophy. Greek philosophers promote logical, rational explanations of natural phenomena. Whatever is happening around the world, they represent with using logical and rational explanation. For example, changing of seasons, lunar eclipse, and so on. A school of logic, science, and mathematics are established. It is the time when science and mathematics schools were opened to impart the knowledge of number systems. Mathematicians achieve fame, are valued for their work. It is a time when mathematicians achieved too much fame and they were called for higher purposes. Mathematics is viewed as more than a tool to solve practical problems. It is seen as a means to understand divine laws. At that time, these were thought as divine laws. Divine laws means coming from the heaven. These are the laws that came from the heaven, and everybody have to follow these laws. Now, the Euclidean geometry. The first mathematical system based on postulates, theorems, and proofs appear in Euclid's Elements. Now we teach postulates and theorems. Postulates are the statements that need not be proved, and theorems are the statements that need to be proved. Mathematics and Greek philosophy. It was a time to see mathematics in three-dimensional. Greek philosophers viewed the universe in mathematical terms. Plato described 5 elements. One is octahedron for air, cube for earth, and tetrahedron for fire. Dodecahedron for the universe, and icosahedron for water. Icosahedron is a three-dimensional figure which is actually made up of equilateral triangles. These are the Euclid elements of different generations. According to Pythagoras theorem, these are all the things same, representing the same thing. That is Pythagoras theorems that we use in modern algebra, modern geometry. It is the famous discovery, Archimedes and the crown. We know it very well. It is the time of Eureka moment when he discovered how a crown made up of gold is pure or not. It is a very, it was an assignment given to him, Archimedes, by the princess to find out whether his crown is made up of pure gold or it is alloyed with something. Actually, he could not understand what to do initially. When he was bathing and he put himself in the water tub, then he found that the volume of water that flow out was actually equal to the volume of his weight, volume of heat. He found out new way to find the purity of the gold. According to him, according to now laws, different objects of different densities show different displacement of water. He took one gold crown given by the princess. It was to be checked whether this gold was pure or not. And another gold he took himself, which was pure gold of the same weight. He dropped these two crowns, one made up of pure gold, another the crown given by the prince. He dropped them into water, but showed that different displacements of water flows out. And now it showed that the ground given by the prince was not pure, because the displacement of water is based on the density, and every objects have different densities. Every metal have different densities. Now Indo-Arabian period, around 200 BC to 1250 AD, development and spread of Indo-Arabic numbers. A numeration system using base 10, positional notation, the zero symbol, and powerful arithmetic techniques is developed by the Hindus approx 150 BC to 800 AD. The Hindu numeration system is adopted by the Arabs and spread throughout their sphere of influence. Preservation of Greek mathematics. Arab scholars copied and studied Greek mathematical works, principally in Baghdad. Development of algebra and trigonometry. Arab mathematicians find method of solutions for quadratic, cubic, and higher degree polynomial equations. The English word algebra is derived from the title of the Arabic book describing these text methods. Hindu-Arab trigonometry, especially sine tables, is improved and advanced by Arab mathematicians. It was the time when Arab and Hindus came together to develop a new method for algebra, and a scientist and a philosopher named Al-Zawari come with the word algebra. He showed how to develop square root and cube root for any numbers. This is a great mass of word robot. Architecture was not too much developed, but it has the capacity for all the players of the city to come under the same roof. It is a huge mosque, and it has many more pillars and vertical columns that draws different architects from the world and travelers from the world. During the Middle Ages, Cordoba was the greatest center of learning in Europe, second only to Baghdad in the Islamic world. Islamic astronomy and science. Actually, Islamic rituals is based on suns and moon. But at that time, there was nothing to calculate these. And one more thing, that need to find how to find the directions of Makkah, because every namazis have to offer facing their directions Makkah in front of them. At that time, a compass was developed. Many of the sciences developed from needs to fulfill the rituals and duties of Muslim worship. Performing formal prayers required that a Muslim faces Makkah. To find Makkah from any part of the globe, Muslims invented the compass and developed the sciences of geography and geometry. As we know, prayer and fasting require knowing the times of each day, because these times are marked by astronomical phenomena. The science of astronomy underwent a major development. He is a renowned philosopher, scientist, author, mathematician, Al-Khwarizmi, Abu Abdullah Muhammad bin Musa Al-Khwarizmi, around 800 AD. He is the father of algebra. He developed how to find square root, cubic root, solve quadratic equations and cubic equations, cubic polynomials at that time. It was the time when he used pen and paper and solved many quadratic equations. He developed the concept of an algorithm in mathematics that is still studied. The words algorithm and algorithm derive ultimately from his name Al-Khwarizmi. His systematic and logical approach to solving linear and quadratic equations gave shape to the discipline of algebra, a A word that is derived from the name of his book on the subject is al-Jabr. Al-Muqabala, Al-Jabr became Algebra. He was also instrumental in promoting the Hindu-Arabic numeration system. These are some symbols used for 1, 2, 3, 4, 5, 6, 7, 8 and 9. 0 came after. The first one is Hindu, Brahmi. The second one is Hindu, warrior. The third one is Hindu, Devanagari. The fourth one is West Arabic. The fifth one is East Arabic. And the European. After that, last one, numerals that still move till 0 to 9. How discovery of Greek and Indo-Arabic mathematics took place? Greek mathematics texts are translated from Arabic into Latin. Greek ideas about logic and geometrical reasoning and rational view of the world are rediscovered. These are the things that rediscovered. Mixing of Hindu and Arabic mathematicians. That is why they be called in Hindu-Arab mathematics. Arab works on algebra and trigonometry are also translated in Latin and disseminated throughout the Europe. It was a time when Hindu-Arabic numeration system spread from and spread over Europe and rest of the world. And it is a time when pen and paper arithmetic algorithm based on Hindu-Arabic numerals replaced the use of abacus. Before it, Chinese abacus system, Egyptian and many more civilizations have developed their calculators, but after that, pen and paper arithmetic that was of no use. I will show you a video that can clearly demonstrate how mathematics evolved.
Sumerian clay stones have been found that date to the 4th millennium BC. A small clay cone was used for 1, a clay ball was used for 10, and a large cone stood for 60. Written records from around 3300 BC show that Babylonians inscribed amounts on clay tablets with a reed. They used a nail shape for 1s and a U on the side for 10s, combining these symbols to write other numbers. For example, Babylonians wrote the number 19 as the ancient Egyptians used objects from their everyday life as symbols. A rod stood for 1, a cattle hollow was 10, a coiled rope was 100, a lotus flower was 1,000, and so on. The number 19 was a cattle hollow and 9 rods. The early Romans created a number system that we still see today. Along with other symbols, they used an X for 10 and an I for 1. Now in the Middle Ages, Romans would show the I to the right of the X for 11, to the left for 9. So they wrote 19 as XIX. All these created number systems show groups of objects as well as individual objects. Some of the oldest human counting systems rely on fingers and toes, so they were based on 1s, 5s, 10s, and 20s. The Zulu word for 6 means to take the thumb of the right hand, meaning that all the fingers on the left hand have been added up, and the other thumb is weakened. Other systems evolved from counts. The Yoruba in Nigeria used cowrie shells as currency and developed an amazingly complex number system. It was based on 20s and on the operations of multiplication, subtraction, and addition. For example, they wrote 45 as 3 times 20 minus 10 minus 5. Amounts tied in chords and strings were used for recording amounts by many cultures, like the Persians. The Incans used a more refined version called a kipu, a thick cord held horizontally from which hung a knotted string. The kind of knot the Indians used along with the length and color of the cord represented ones, tens, and hundreds. In today's world, almost every industrial culture uses the numerals 0 through 9. But these symbols weren't invented until the 3rd century BC in India, and it took another 800 years for the idea about zero as place value to be constructed. This big idea dramatically changed the face of mathematics. We humans always shared with one another. When early cultures shared their food and water or wanted to divide their land in ways that were fair and equal, fractions gradually emerged as symbols for these fair shares of weight. The ancient Egyptians used unit fractions. Fractions where the numerator is 1, like 1/2, 1/3, and 1/5. And they add and half these fractions. If they wanted to divide.
In this video, it has been clearly seen how evolution takes part, how evolution of mathematics takes part, and inspire us to evolve it and make it more proper to use for further generations. We need to preserve these things for future generation to know how these systems came into being. And these are the 9 figures of the Indians, 9, 8, 7, 6, 5, 4, 3, 2, 1. With these 9 figures and the sign 0, which in Arabic called Zafrium, any number can be written as it is illustrated. It is the part, it is the statement given by him that any numbers can be made using these digits. Actually, these digits we use till date. Abacists and algorists compete. She is a lady, arithmetic, and used certain ways for her judgment by smiling on arithmetician and working with Arabic numerals and the 0. At that time, she showed her skills how to give any judgment using her mathematics skills. That is why she has got the name Lady Arithmetic. As we have developed Greek geometry, it is a time to rediscovery of Greek geometry. Luca Pacioli, a physician prior and a mathematician, stands at a table filled with geometrical tools, dodecahedron, model, etc., illustrating a theorem from Euclid while examining beautiful glass. Actually, he is explaining a theorem by using some practical means, by using a beautiful glass filled with water. He demonstrated that if any theorems can be developed using a practical model, then that they can never be forgotten. It was his idea, and I think it is the best idea to explain any mathematics for our children, for our students. These are the 3-dimensional figures. Actually, it has already been told that these are made up of equilateral triangle and were used for some purpose. The figure shown here is a drawing of an icosahedron and an elevated form of it. For the elevated forms, each face is augmented with a pyramid composed of equilateral triangle. These were the shapes that they used in their constructions, buildings, architects, and many more. Now it is a time for early modern period. Trigonometry and logarithm. Actually, we have developed now logarithm table and trigonometric table that we use in our general life for the construction of any building and architect. publication of precise triviality tables, improvement of surveying methods using triviality and mathematical analysis, theoretic relationships. Logarithm introduced in Napier in 1614 as a calculation aid. Still used log table to find acidity or basicity and many more in mathematics terms. This advances science in a manner similar to the introduction of the computer. At that time, this was thought as if now the computer is thought. It was a time when it was thought that it is a great discovery, great evolution of mathematics, as we thought that is basic computer is today now. Symbolic algebra and analytic geometry. Development of symbolic algebra. Principally VAT and Descartes. VAT and Descartes are the French mathematicians. We have to use certain theorems and postulates to build some structures as well as in modern roads, canals, etc. The Cartesian coordinate system that we still use to find distance, to find areas and many more things. And analytic geometry developed by René Descartes and Pierre Fauvet. Now the creation of calculus. It was a time when calculus was created. Calculus was co-invented by Isaac Newton and Gottfried Leibniz. Major ideas of the calculus expanded and refined by others. Actually, they created calculus, but after that, modified by some scholars, especially the Bernoulli family and Leonhard Euler. Actually, this Germany is called Euler. We read it Euler. A powerful tool to solve scientific and engineering problems. It opened the door to a scientific and mathematical revolution. We use this calculus in our graduations and masters to solve certain problems. He's created and his symbolic algebra. He discovered many symbolic algebras that we still use and named it VAT and symbolic algebra. In his influential treatise in Atom Analyticum, as a quote, Introduction to the Analytic Art, published in 1591, VAT demonstrated the values of symbols. He suggested using letters as symbols for quantities both known and unknown. That time, two types of quantities. One was issuing the variables and other constant, and certain other symbols to find any of the problems. Now it is time to show how the numbers from 0 to infinite is invented through a video.
शून्य से कहानी गणित मानवता और गणित दोनों का विकास बिल्कुल साथ साथ हो और दोनों एक दूसरे में ऐसे उठ गए हैं कि आप उन्हें अलग नहीं कर सकते। लेकिन जब भी मानव के विकास की कहानी सुनाई जाती है, गणित की कहानी छूट जाती है। आज उसी गणित की कहानी जिसकी पीठ पर दुनिया का सारा विज्ञान ही नहीं, कलाएं भी इसी गणित पर आई है। ये जो आप सुन रहे हैं, ये है 16 बीट्स यानी मात्राओं वाला 3 ताल। एक ज्यादा या एक कम, ये संगीत से शोर बदलती है। महान यूनानी गणितज्ञ पाइथागोरस ने संगीत और गणित का रिश्ता ईसा मसीह की पैदाइश से कई 100 साल पहले खोज लिया। स्थापत्य कला, चित्रकला, मूर्ति कला सब गणित के नियमों से चलते हैं। आकार और अनुपात को समझे बिना किसी तरह की कोई रचना संभव नहीं है। वैज्ञानिक बताते हैं कि कौड़ी से लेकर चिंपांजी कई जीव जंतु 5 से 7 तक जीव सकते हैं। इंसान ने पहले कहाँ और कब गिनना शुरू किया, ये कोई नहीं जानता। लेकिन सबसे पहले लिखने और अंकों को अंकित करने के प्रमाण आज के इतिहास, जिसे तब बेबीलोनिया कहा जाता था, वहाँ और मिस्र में मिलते हैं। 5000 साल पहले बने पिरामिड इस बात का अंदाजा देते हैं कि ज्योमेट्री या जियोमेट्री का विकास भी काफी पहले शुरू हो गया था। जाने माने गणितज्ञ मार्कस टूसॉ समझाते हैं कि ज्योमेट्री के ज्ञान के बिना पिरामिड जैसे स्ट्रक्चर नहीं हो सकते।
For me, the most impressive thing about the pyramids is the mathematical brilliance that went into making them.
मेरी नज़र में पिरामिड की सबसे खास बात उसे बनाए जाने में गणित का अद्भुत इस्तेमाल है। ये प्राचीन यूनानी गणित के पाइथागोरस के फॉर्मूले का व्यवहारिक रूप है। प्राचीन मिस्र में एक परफेक्ट समकोण या राइट एंगल बनाने के लिए बराबर दूरी पर गांठ लगी रस्सी का इस्तेमाल नापने के लिए किया जाता था। इसका फॉर्मूला था पहली भुजा 3 गांठ लंबी, दूसरी 4 गांठ लंबी और तीसरी 5 गांठ लंबी। 5000 साल पहले पत्थर, रस्सी, लोगों की मेहनत और गणित के जादू से बने चमत्कारी पिरामिड।
चीन गणित की कहानी का अगला ग्रेट वॉल ऑफ चाइना, हजारों किलोमीटर लंबी दीवार जो सदियों तक बन।
Now at last, I want to introduce regarding current branches of mathematics that we study. Foundations, algebra. There are types of algebra, like group theory, ring theory, module, combinators, algebraic geometry, and so on. Mathematical analysis, geometry and topology, applied mathematics that we teach them students in schools. Now that's all for the today. Thank you.